All right, hopefully you found the correct video. This is Algebra 2, lesson 8.1, and it's function operations. Kind of a neat lesson, function operations. So an operation would be addition, subtraction, multiplication, division. Only in this case, we're going to do the operation on functions, not on just numbers. Okay, so let me try by way of introduction to get you to understand the overall concept and some principles that are involved. And to help us better understand that, I've got an f of x function, and it's the purple one right up here. And so I also graphed it. So I have f of x equals negative 1/2 x plus 2. And so I graphed the y-intercept of positive 2. From there I went down 1 and to the right 2, and I drew my purple function. All right, I'm going to use red for your guys' sake. And then we've got a blue function, g of x equals x plus 1. All right, so the g of x function, y-intercept of 1, and then from there a slope of 1, so up 1 and to the right 1. You can see the blue line there representing the g function. All right, so purple line representing the f function and blue line representing the g function. I'm just going to say red and blue from here on out. Okay, so the first operation that we are dealing with is addition. So what this notation means is I want to take the f function and I want to add to it the g function. I want to take the f function, I want to add to it the g function. Okay, so I'm going to take my red here, I'm going to take the f function, negative 1/2 x plus 2, and take my black here, and to that f function, I want to add, I'm going to take my blue, the g function. What is the g function? The x plus 1. Now, remember, the red one could be y equals negative 1/2 x plus 2, and the bottom one, the blue one, could be y equals x plus 1. And it's what the y equals that is the function or the rule of the function, and that's what we're going to add. So we're adding this part and that part, right? Got it? Okay, so let's go ahead and do that. And I'm going to fill this in black. Negative 1/2 x and positive 1x gives me a positive 1/2 x, and we all know 2 plus 1 is 3. Okay, so here's the answer. F plus g of x equals 1/2 x plus 3. I'm going to graph that. All right, y-intercept of 3. And then the slope of 1/2, I'm going to go up 1 and to the right 2, and I'm going to put a bunch of these on. Up 1 to the right 2, up 1 to the right 2, and I'm going to start back at 3 again and do it the other way. Down 1 to the left 2, down 1 to the left 2, down 1 to the left 2. Okay, so I want to get that function just in the right place. So there's our line right there. Okay, this is f plus g of x. Now here's the neat thing. We are adding functions. And remember, the function is you input a value and you get some kind of output value. And the input are the x's, goes along with the horizontal x-axis, and the output are the y's, goes along with the vertical y-axis. So notice a couple things right here. Let's start with an input of 0. Now, don't do this in your notes because things will get too complicated and it won't make any sense to you. So I think you're just better off just watching at this point now, okay? So I'm right here at the origin. I've got an x value, an input of 0. All right, take the red function, and notice its output is 2. So input 0 for the red function, output 2. Look at the blue one. Input 0, and for the blue one is an output 1. What do you get when you add 2 and 1? The output of our f plus g function. Did you catch that? Let me show you again with 2. What if we were going to do an input of 2? All right, for the red function, if we input 2, we output 1. For the blue function, if we input 2, we output 3. Guess what? 1 plus 3 is 4. You can do this for every point. Now, I'm just doing the obvious ones, but it's no different. I don't know. I'll take 3.5. That value plus that value equals that value. Here, let's do negative 2. What is the output of the g function? the red function, I'm sorry, the f function, is 3. What's the output of the blue one? -1. What's 3 minus 1? 2. You can do it everywhere. I mean, that's the situation. F of -4. The f function's output is 4, but the blue function's output is -3 for a grand total of +1. That is the case. We're adding the functions. So it's just like adding the outputs for any given input. Hey, that's the way it goes. All right, let me erase this so I can show you the analogies of the other ones. Don't worry about your notes, just leave them the way they are. All right, so let's look at the second situation. The second situation, I want to take the g function and I want to subtract from it the f function. And we'll go over all these again in more detail and fill in exactly how to do them. And I'm just trying to get you to understand the concepts right now. Okay, so in this situation, so my g function is x plus 1, and I want to subtract from it my f function, which is -1/2 x plus 2. However, here's the key. I need to subtract the whole f function from it. So do you see already how this negative is going to distribute? So what do you get when you do the g function minus the f function? Okay, +1x and a +1/2x is a +1.5x or 3/2 x. And a +1 and a -2 when I distribute is a -1. Here's what you get when you take the g function and subtract from it the f function. So let me graph this. All right, y-intercept of -1. I'll graph that first. And I have a slope of 3/2. Up 3 from there and to the right, 2. Up 3 from that point to the right, 2. I'm going to start back at -1, down 3, and to the left, 2. And that's about all the room I have, and that's good enough. So now the same thing is going to hold true. For any given input, if you'll take the g output and subtract from it the f output, you'll get our g minus f function. Okay. So again, if you look at 0, again, you don't need to do this in your notes. Don't draw that function in your notes. Just watch. So input of 0. What is our blue output? It's a 1. Minus our red output, 2, for a grand total of -1. And this is the case. Input of 2. Again, what is our blue output? 3. Minus our red output of 1. 3 minus 1 is 2. Let's do 4. What is our blue output? It's a 5. What is our red output? 0. 5 minus 0 is 5. And again, you can do this everywhere on the graph. Now, specifically for this question, look back over here at B. We specifically want g minus f of 2. So that the real answer, the total answer to this thing is actually, what do you get with an input of 2? And so technically the answer is 2. And we could have done that mathematically as well, and I'll show you how to do that a little bit later. All right, let me clear this out. And I'm going to speed up a little bit here, so I don't want an hour-long video. All right, so the third one is division. So we're going to divide the f function by the g function. So this one, a little bit more involved. -1/2 x plus 2. And we're going to divide by x plus 1, and it's just a bunch of stuff there. But here's the point. For division, again, I could take any point of the red and divide it by the x input of the blue, and I'll get the black. So on this one, I'm just going to go by that to draw the function. So I'm going to grab my black. Again, don't do this in your notes because you have stuff all over the place. So let's do 0. Let's do an input of 0. Got to take the top, output of 2, and divide it by an output of 1. 2 divided by 1 is 2. So I know I have that point right there. All right, and again, I'm looking for points I can figure out. So I'm going to go to 2 now. My F is a 1, and my blue is a 3. That's a 1/3. So that's going to be about there, right? 1/3. That's what I get. Let's do 4. All right, I got to take my red 0 and divide it by 5. 0 divided by anything is 0. I have that right there. Let's go on the negative side. Let's go -2. So I've got an output of 3. And this is actually the question, right? What is F divided by G of -2? I have an output of 3. And divide it by a -1. 3 divided by -1 is a -3. So I have that value. So look where my values are. They're all over the place. I've got an output there. I've got an output there. I've got an output here. I've got an output here. But I'm able to figure out all these outputs because I'm dividing the F value output by the G value output. Okay? And then the last one is multiplication. And again, we're going to multiply, but we're just going to do G times F of -4. So let's just go to -4. Okay, let me grab my black here. We're just going to go to -4. What is the output of G? A -3. What is the output of the red one, the F, a +4? -3 times 4. The solution to that is a -12. We're multiplying the function. So we'd multiply every time the blue output times the red output for any given X input. All right, I know that's kind of weird looking stuff, but that's the way those go. Okay? Hey, come back and look at this a week from now, and it'll begin to make even more sense to you. All right, so let's put it into use here with some functions here. So the 5 basic operations of functions. I have 3 example functions: h of x, j of x, k of x. All right, first off, here's the rule. What if you have f plus g of x? What does that mean? All right, that means you take the f of x function, and we take a green for the plus sign, and you add to it the g of f function, g of x function. You add the 2 functions. Okay? So the first example on the left, take the j function and add to it the h function. So what is the j function? 2x plus 1. Take my green here. To that, I must add the h. And what is the h? 3x plus, minus 1. 3x minus 1. Okay, add like terms. 5x is where you end up, right? And that is the j function plus the h function. Now notice the difference in the second example here to the right. We want to add the h and the k, but now we want to add when the input is 3. So watch what I'm going to do on this one. I'm doing it underneath for space sake. I'm going to take the h function, and everywhere where the variable is, I'm going to put in a parentheses, right? Because we have to input a 3 for the variable. So that's the h function. We'll take the plus sign in green, and now I want to do the k function. And again, everywhere where the variable is, I'm putting a parenthesis so I can go back in and put in that 3. All right, so 2 parentheses x squared minus 5x parentheses minus 3, and now we got to put in the input of 3 each time. Okay, so this is a 9. This is a 9, which is going to end up being 18. That's a -15, right? And a -3. So 9 minus 1 is 8. 8 times 8 plus 18 is 26. Minus 15 is 11. 11 minus 3 is 8. So h plus k of 3 is 8. And that's how you do those. Okay? So the left one, we had to leave the variable in there because it's of x. But on the right one, we get a numerical value because we found the output when you add the input for the h function, when the output of the h when the input's 3, and the output of the k when the input is 3. All right, second one is subtraction. Biggest key here is to be careful to make sure that it's minus the whole second function. So this is going to be f of x, big red minus sign, and then the whole g of x function. And I'll show you here that in a minute when we do our example. F of x minus g of x. Okay, so look on the left here, we have the j function comes first, and it's 2x plus 1. Then we have our red minus sign, and remember, there's going to be in a parentheses. So I'm going to start with a left parentheses. Now I'm going to put the h function, 3x minus 1, and then I'm going to close that, because again, it has to be minus the whole h function. And remember, we're going to distribute this. Okay, so now where do you end up? You end up at negative x plus 2 is what you get when you do the j function minus the h function. Now again, the second example, we want a specific output. We want the output, we want the k minus the j for the input of negative 2. Okay, so I'm going to take the k function. I'm going to do this underneath so I have more room, and wherever the variable is, I'm going to put a parenthesis so we can put in that negative 2. Okay, that's k. I'm going to take my red minus parentheses. What is j? 2 parentheses for the x plus 1 close parentheses. And here I'm going to do it in blue. I'm putting a negative 2 in every time. Negative 2, negative 2. Okay. So in the front, negative 2 times negative 2 is 4. 4 times 2 is 8. That's an 8. Negative 5 times negative 2 is a positive 10. We still have negative 3. Then we have minus. So let's do everything inside the parentheses. 2 times negative 2 is a negative 4. Negative 4 plus 1 is a negative 3. So it'll end up being a positive 3. And what is the answer to this thing? So 8 and 10. And then negative 3 plus 3, and so that thing ends up 18. Okay? All right, let's go on to the next one. Third operation is multiplication. On this one, you're simply multiplying the two functions. It's f of x. You can use a raised dot here, times g of x. You got to multiply the two. Here, let me get rid of my shade and go higher for you guys. Okay, so come back a little. Oh, come on, Windows 7. Stop doing this. What a pain. All right. Okay, so let's do hj of x. So what is the h function? It's 3x minus 1. That's got to go in parentheses. And what is the j function? 2x plus 1. That's got to go into parentheses. And do you see now how you got to multiply out the two binomials? And again, look, this is Algebra 2. I'm not going to take time to multiply it all out. What do you get? 6x squared, positive 3x, and negative 2x. That's a positive x minus 1 is the multiplication of that. Now again, the second example, we get to put 1 in where the variables are each time. So what's the h function? 3 times 1 minus 1. And what's the k function? 2 times 1 squared minus 5 times 1 minus 3. So what's the first? Front parentheses is a 2. And the back parentheses is a 2 minus 5 is a negative 3. Negative 3 and another negative is a negative 6 for a grand total of negative 12. If I did that right, I'm going fast here, so hopefully that's good. Okay, and then division. So same concept, right? You're catching on now? It's going to be our f of x function divided by our g of x function. F of x divided by g of x. All right, look at the first example here. Hey, give yourself some room up above. You're going to need it. What is our k function? 2x squared minus 5x minus 3. And what is our j function? 2x plus 1. Now, do you remember how to reduce polynomials? Let's see if this top factors. 2x and x. We got to get a negative 5 in the middle. So if I had a negative 3, that would be a negative 6 and a positive 1. That gets me a negative 5 in the middle, right? So that's the correct factorization. And look, oh, it does reduce. This divided by that is 1, and what's the solution? X minus 3. Always be aware of that in division. Again, in the second example, we're going to be able to put in the numbers because we have an input of 2. So what is our h function? 2 times 3 is 6, right? I'm looking right here. I'm putting 2 in for the x. 2 times 3 is 6. 6 minus 1 is 5. Top's of 5. What's our j? 2 times 2 is 4. 4 and 1 is 5. Bottom's of 5. What's the value of that? 1, right? When you divide the h output by the j output for an input of 2, you get 1. All right, again, that's on video. You can go back and look at it. There's one other operation you have to be aware of. So I've got 3 more example functions, and this operation is called composition. Composition. So it's composition of functions. It can really be shown 2 different ways. The notation could be like this. Almost looks like fog, right? But instead of a raised dot, you have a raised circle. That's the composition symbol. Or you can have this notation, which is what I prefer, which is really descriptive of what's going on. So you got the raised circle, or you've got the actual notation that really kind of shows you what's going on with the function. Okay. What does it mean? How do you do composition? All right. Well, here's what you do. It matters the order. The order definitely matters. Notice the k function is listed first. So I need to take the k function, and everywhere where the variable is in the k function, I'm going to put in a parentheses, and don't make it little. Notice mine is big. So 2x squared, so 2 parentheses squared, minus 5 parentheses for the x, and then back to my black, minus 3. So there's the f, excuse me, there's the k function. All right, the first one that's listed. And wherever the variable was, I left parentheses. Why do I like the second notation? See, the second notation tells me to put the g function in for the variable. And that's exactly what you do for composition. So in this situation, I need to put the h function in for the variable. So here's the h function. So in this parentheses, I put in 3x minus 1. In this parentheses, I put in 3x minus 1. I got to multiply all this stuff out. And remember, this first one is 2 binomials. So that's just 2 times 3x minus 1 times 3x minus 1. And so let's do this part and get it over with. This is 2 times a 9x squared. A negative 3x and another negative 3x is a negative 6x. And a negative 1 times a negative 1 is a positive 1. Look, I'm just distributing. Again, this is Algebra 2. We should be able to do that in our heads. If you can't, take the steps and take the time and do that. Okay, here I've got the negative 5 times a 3x for a negative 15x, a negative 5 times a negative 1 for a positive 5, and then you still have this negative 3 on the back. Now in all this, I still have a 2 to distribute, 18x squared minus 12x plus 2, and then still the negative 15x plus 5 minus 3. You might say, Mr. Scarfi, these are long. You know what? We're going to make a way to make them shorter for you, and you'll see that in a minute, okay? But this is the principle, and this is what's involved, and this is how you do these. So you got to put in the whole second function in for the variables of the first function. Let's finish it out. We've got an 18x squared, negative 12 of them, and a negative 15, and negative 27x. And then 2 and 5 is 7. 7 minus 3 is a 4. So 18x squared minus 27x plus 4 is the composition of h sorry, k composition h of x. Hey, that's nothing that's hard. It's got a few steps to it. Now, sometimes they're easier. Look at the second example. So we're doing h composition j of x. Okay, so you got to start with the h function. So I start with a 3, and then I get to its variable, and that's where I need the parentheses, and then the minus 1. So again, if you look at h, 3x minus 1, 3 parentheses minus 1. And what do I put in the parentheses? The whole j function, which is 2x plus 1. Now you can see this one's not as complex because we didn't have a squared term. Much easier to deal with and handle. 3 times 2x, 6x, 3 times 1 is 3, minus 1, finish it off, 6x plus 2. And we composition those functions. Now life can be easier if they give you an input value. So you look at the third example, and I know that's kind of low for you guys, but you can see it there in your notes. Now we have an input of 2 for the variable. Okay, this is still composition. Let's see, I'm going to put it the other way for you. It would have been k, raised circle, j, parentheses, comma, 2, parentheses, 2, parentheses. So k, raised 0j, all in parentheses, and then parentheses 2, close parentheses. Same thing. Okay, so what do? I take the k function, which is 2 times x squared minus 5 times x minus 3, right? Wherever the x is, I'm putting that parentheses. I'm going to take my red here, and now I have to do j of 2. But look what's going to happen when I do j of 2. 2 times 2 plus 1, right? Isn't that j of 2? And the same thing here, 2 times 2 plus 1. Oh, this is easier because we get a number. So again, wherever the x was for the variable for the k function, I put in all of j. And because we know we want it for an input of 2, I put 2 in where the variable was of j. See, right here was the variable of j. So really, what is j of 2? J of 2 is a 5. So now I have 2 times 5 squared, which is 50, right? 5 squared is 25 times 2 is 50. Negative 5 times 5 is a negative 25 minus 3. And what do we end up with? A grand total of 22. And we just composition that function. Not so bad. Composition. Start with the first function, where the variables are for the first function. Put in the whole second function. All right, last question. If f of x equals the quantity x plus 1 to the half, and g of x equals x to the negative half, negative 2, I'm sorry, find f composition g of x and give the domain. And give the domain. Okay, we can handle this. Let's change the form a little bit. Would you agree that the f of x function is what kind of function? Right, last chapter, what's a half exponent? And hopefully you say, okay, that's a square root. I can do that. So f of x equals square root of x plus 1. All right, g of x, negative exponent. Look, we've been doing this rule since pre-algebra. X to the negative 2 equals 1 over x squared, right? Now we got a composition. So again, the composition, the f composition g of x, or the format I really prefer, I take my f function, and where the variable is, I put a parentheses, and then I stub into the variable the g of x function. So I get f of x equals the square root of 1 over x squared plus 1. I don't know why I said give the domain, because who knows really on this one. We got the square root of 1 over x squared, and that's complicated. All right, that is complicated. And so don't worry about that part. I do want to do this though. Last thing that we're going to do. What if perchance, what if we did F composition G of, oh, let's see. Let's do 9. So everything would be the same, right? The difference would be on the bottom. Let's do 3. And that's what I was thinking. Again, what was example I was going to do? Let's do 3. F composition G of 3. Sorry about that. So now where the x is, it's going to be a 3 squared, right? Plus 1. Okay, so look what happens on this one. A 1 over 3 squared is a 1/9 plus 1. Agreed? Let me go a little higher for you guys so you can see a little better in class here. Okay, so come on, Windows 10 cooperates. Oh, sorry about that, guys. Okay, so 1/9 plus 1, so 1/9 plus 9/9 is 10/9. And can we simplify that? Oh, yes. Square root of 10 over the square root of 9, which is 3. And we get the square root of 10 over 3. F composition G of 3 would be the square root of 10 over 3. All right. Functional operations. Adding the functions for any given input. Add the outputs. Subtracting the functions. Any given input, subtract the outputs, dividing the functions, any given input, divide the top output by the bottom output, multiplying functions, any given input, multiply the outputs. That's the case. So we did all those, and then remember composition. We'll come up, we'll deal with these a little bit later in the chapter and make application with them. But again, the order is important. You take the first function where the variables are located for the first function, sub in the whole second function, and solve from there. All right, that's it. And we're flipped tomorrow. Well, that'll actually be Tuesday for you guys because of President's Day. And so we're flipped. And so the homework will be worked in class on Tuesday. All right, hope you enjoy your weekend.